So in this video, we're going to factor some trinomials with leading coefficients of 1. In this problem, we're asked to factor the polynomial x squared plus 12x plus 35. And anytime we're asked to factor a polynomial, the very first step that we take is to look for a GCF amongst all the terms in the polynomial. Well, as we look for a GCF amongst x squared, 12x, and 35, we find that there is no GCF. Once we've looked for a GCF, the next step in factoring any polynomial is to count the number of terms, because the number of terms that are in our polynomial will help us determine the strategy we're going to use to factor it. This polynomial has 3 terms, and I notice that the leading coefficient is a 1. So this is a trinomial with a leading coefficient of 1. Trinomials with a leading coefficient of 1 will factor into 2 binomials, and that will always be the case. So I just go ahead and make room for 2 binomials. Now let's find the first term in each of our binomial factors. The x squared here is the result of multiplying the first term by the first term. And the only way to get an x squared is if this first term and this first term are both x's, because x times x gives us x squared. Now to find each of the remaining terms, here and here, remember, I have to find 2 numbers that when multiplied together give me the last term in the polynomial. But those same 2 numbers also have to add to give me the coefficient of the middle term in the polynomial. So I need 2 numbers that when multiplied give me 35, but when added give me 12. So let's think this through. What are all the different ways that I can multiply 2 numbers and get a positive 35? Well, obviously, one of the first ways is 1 times 35. Another way is negative 1 times negative 35, because a negative times a negative will also give me a positive 35. Another option might be a positive 5 times a positive 7. And then finally, a negative 5 times a negative 7 will also give me a positive 35. So those are all the different ways we can multiply 2 numbers and get positive 35. But now I have to pick the right combination that when I add the 2 numbers together, I get 12. So I'm going to take all of my multiplication symbols out now, and I'm going to put a plus between all of them, because now I need the numbers that I choose to add to get 12. Well, obviously 1 plus 35 isn't going to work. Negative 1 plus negative 35 is negative 36. That's not going to work. 5 plus 7? 5 plus 7 is 12. 5 times 7 gives me 35, and 5 plus 7 gives me 12. So the numbers that I'm going to fill in for my second terms are going to be a positive 5 and a positive 7. And that is the correct factorization of x squared plus 12x plus 35. All right, let's look at this example. Here we're asked to factor the opposite of x squared plus 2x plus 15. The first step in factoring any polynomial is to look for a GCF. And if you remember in a previous video, we talked about if our leading coefficient is ever a negative, that negative should always be part of our GCF. So here I notice that my leading coefficient is a negative 1. So we're going to go ahead and factor out that negative, or the negative 1 if you want to look at it that way, and include that as part of our GCF. When I look at the remaining terms, x squared, 2x, and 15, I find that they do not have a GCF in common other than the negative 1 that we've already identified. So we're just going to say that our GCF here is a negative 1 because our leading coefficient is negative. So let's factor out the GCF of negative 1. All right, when we factor a negative 1 from the opposite of x squared, we're left with x squared. When we factor a negative 1 from 2x, we're left with minus 2x. And when we factor a negative 1 from positive 15, we're left with a negative 15. So step number 1 is complete. We've factored out our GCF. Now we take a look at our remaining polynomial inside the parentheses and see if we can continue factoring that polynomial. I notice that this is a trinomial with a leading coefficient of 1, and I'm pretty sure I can keep factoring this trinomial. So let's go ahead and begin the factorization process. Remember, each time we take a step in the factorization process, our GCF must come down every single time. If we don't bring down the GCF in each step, the end result will be the incorrect factorization. All right, so I brought down my GCF, and I know that this x squared minus 2x minus 15 is going to factor into a binomial times a binomial. So I've gone ahead and made space for my two binomials there. The first term in each binomial, I know when I multiply them, has to give me x squared. The only way for that to happen is for the first term in each binomial to be an x. The second term in each binomial, here and here, have to be numbers that when I multiply them give me negative 15, but when I add them give me negative 2. Let's do some figuring over here on the side to see if we can come up with the right number combination. Negative 1 times positive 15 gives us negative 15, or 1 times a negative 15 will also give us negative 15. Negative 3 times 5 is another option, or 3 times negative 5 is another option. Now, I believe those are all the different combinations of multiplying two numbers to get negative 15. So now let's change all of those multiplies to adds, because I know that the number combination that I pick has to add to give us negative 2. Negative 1 plus 15 obviously is not going to work. 1 plus a negative 15, well, that's just 1 minus 15. That's not negative 2. Negative 3 plus 5, that's a positive 2. That's close. But 3 plus a negative 5, which is 3 minus 5, that's negative 2. That's the right combination. So we need a positive 3 and a negative 5. 3 times negative 5 gives us negative 15, and 3 minus 5 gives us negative 2. So the correct factorization is negative 1 times the binomial x plus 3 times the binomial x minus 5. Let's look at this example. Here we're asked to factor x squared plus 2x plus 3. The first step to factoring any polynomial is to look for a GCF. So is there a GCF between x squared, 2x, and 3? No. Step number 2, figure out what kind of polynomial we're working with. Well, this is a 3-term polynomial with a leading coefficient of 1. So this is a trinomial with a leading coefficient of 1. And we know that trinomials always factor into a binomial times a binomial. And we know to get the x squared here, each of our first terms must be an x. Now we need two numbers that multiply to give us 3 and add to give us 2. 1 times 3 gives us 3, and negative 1 times negative 3 also gives us 3. But there's no other combination of multiplying two numbers that will give us a positive 3. So now let's change our multiplies to adds, because we know that the correct number combination not only multiplies to positive 3, but adds to positive 2. 1 plus 3 is 4. That doesn't work. Negative 1 plus negative 3 is the same thing as negative 1 minus 3. Well, that's minus 4. That combination doesn't work either. So it appears we're at an impasse and that we can't find the correct combination to factor this polynomial. This sometimes happens. And when it happens, we say that this polynomial is prime over the real numbers. So if you run across an example like this where there's not a GCF and the right number combination is not there, then just say that that polynomial is prime and therefore it cannot be factored.